Hello everybody. So today I will teach you a new topic of this unit. Topic is a normalization, relational design principles. So this is the content of this slide. We'll talk about a functional dependency, fixing functional dependency, transitive dependency, functional dependency, full functional dependency, normal form, first normal form, second normal form, third normal form. Another example, solution. Let's just talk about the surrogate and the finally surrogate keys, and finally summary. Functional dependency. The goal of a good relational design is to design meaningful entities and relationship between them, with ultimate aim of minimizing duplication. Duplication is not so much a waste of storage space as it's treated of consistency when we repeat values. We may update one copy but not the other, and we may have different value where we should have the same. Looking at the example, we have twice the postcode 3022 and the Melbourne suburb of Prahran. Actually, 3022 is not the postcode of Prahran at all. Suppose someone realized this while working on one employee file, the file of Peter Smith. They correct the suburb or to area, which is the location that actually has the postcode of 3022. Someone else works on the file on Lan Nguyen and observed the same problem, but in this case, the person decided to suburb must be correct, but the postcode is not. So she corrects the postcode to 3181. Assuming that Peter and Lan actually do live in the same suburb, we have now introduced a mistake. The actual problem here is flow functional dependency. We can assume that the primary key is the reason is employee ID. ID attacks that uniquely identify an entity. If you know the staff ID of a person, you know exactly which person we mean. There is no doubt as to what the person's birthday is, and there is no doubt about what the person's name might be. The employee ID uniquely defines the person so that we can derive all this data. We say that the employee ID functionally determines the birth date, first name, last name, street, even postcode. But then it gets tricky. Actually, the postcode alone is enough to functionally determine the suburb. So in a way, we are doubling up by having both the postcode and suburb in the table. Fixing functional dependency. Most of the time, to fix flow functional dependency, we just split up the table. If an attribute is not generally dependent on the key we have chosen as a primary key in the relation, we figure out what key it is really dependent on and make this key a primary key in a new relation. This is now a tidy one. The suburb is mentioned only once and clearly defined by the postcode. The postcode also has to appear in the original table as a foreign key. Note that we now have a one-to-many relationship. Many employees may live in the same suburb, but only in one at one given time. A transitional dependency is a functional dependency that passes via some other value. In the case of suburb, we cannot actually say that suburb is not at all dependent on the employee ID, because when we know the employee ID, we can tell for sure which suburb the person lives in, just as we can tell what the person's suburb is. but the dependency of the suburb on the employee ID is transitional. Is it actually sufficient to know the postcode to know the suburb? So the dependency of the suburb on the employee ID pass through the postcode, and therefore we say it is transitional. If we need more than one attribute to form a key that uniquely defines all other attributes, we call this a composite key. In the table, you can see that the hour attribute depends on both the staff ID and the project ID, because we assume that the hour means the hour a staff member has spent working on a project. But the staff name clearly only depends on the staff ID, and the project name and the project location clearly only depends on the project ID. We have to assume that the largest set of key forms the actual primary key. Therefore, we choose a composite of staff ID and project ID. If we choose either of them for a primary key, the hour will be hanging in the A. They wouldn't have a dependency on a key. Having chosen the composite key, we realize that staff name only needs half the primary key to be fully defined. We call this partial dependency. Partial dependency are bad. They are so-called design anomaly and indicate potential duplication. Because when a staff member starts working on a different project, we record the hours with the same staff ID and staff name, but different project ID and project name. This means staff name is duplicated and we run into potential consistency problems again. Similarly, if several people work on the same project, we have duplication on project name and the location. So do what we do. We do that we always do relational modeling. Make more tables. As soon as we have identified the key that uniquely describes some attribute, for each different key we create a new table that then holds this attribute with their keys. This approach minimizes duplication of data. You may think, how this minimize duplication when all the key columns are repeated in every table? This is a good point. But if you think about the content of each table, the keys are unique, and therefore the attribute they define will also have unique value. You find that relation design will worry a lot about horizontal redundancy, having the same data in different tuples. We don't worry about vertical redundancy when columns repeat in different tables. Dividing the data up into tables according to functional dependency gives us a database that is sound according to the rational principles. Whether the design is also good one in another story, this depends on your domain, on the actual information you are trying to capture. Normalization of relation schema of a database is the process that ensures the relations are well designed according to the relational models. It is an analysis that takes the relation through a series of tests that make sure the relation don't contain any design anomalies. The tests certify that a relation is in a certain normal form. When a relation is in a particular normal form, we know that it does not suffer from particular anomaly. For example, second normal form eliminates partial dependency. The normal forms subsume each other, meaning that you cannot achieve second normal form without having achieved first normal form. Is it a condition of second normal form that the table is not first normal form and devoid of any partial dependency? It is also a condition of the test for third normal form that your table is already second normal form. Although we have 6 normal forms, practitioners in industry never bother with anything beyond third normal form. In fact, practitioners often deliberately normalize for speed. But this is for another week. We should not have is a database that is not third normal form just because designer doesn't know how to implement third normal form. First normal form. This is an example of the first normal form. A relation in a first normal form if it has no repeating group. So to ensure our table in first normal form, we have to test for repeating groups. This relation describes viewing of rental properties. The responsible staff member at the real estate agents visit a properties and notes down comment about things that the rental things need fixing. We can see that the properties are being inspected about every 6 months. The staff member then takes down possible flaws that need addressing. The same property can be inspected by different staff member. The longer a property is managed by this company, the more inspection trees it has for each property. You can see the predicament with the table structure. Many of the attributes are multi-valued. The entry in this multi-value attribute are all in the same order, so we need to find the second entry in that to match the comment when we need to know when a particular flaw was observed. This is everything but practical and therefore a design anomaly. When we remove the anomaly, we have 1 and F. How do we do this? You see, we already remove the repeating groups. We simply give each inspection a row by itself. Inspection now have a tuple itself. One drawback we observe is that now the property number and address attribute have repeated value. We know that this is not good and we have to fix it. But there is nothing to do with first normal form. Repeating groups come into different variation. The first we have already seen. When there are repeating groups, some database designer try to solve the problem by repeating column groups. Most of the time, this is absolutely trivial design. Why? Well, most of the time we cannot be sure exactly how many groups we have. In the case of property inspection, we can be pretty sure the number will vary. This means we have a large number of columns but many with null values. The other problem is finding the particular visit. If we find a particular inspection by that, we have to look at 3 attributes to find. Inspect that 1, inspect that 2, inspect that 3. This is terribly impractical. It will take a very inexperienced designer to structure a table like this one. People are quite likely to do something like this. When we have expansion, it's like a staff member will find several flaws. It's a good practice not to put them all into same field, but repeating the column is not a good option either. For the same reason as discussed with the last example, we don't want a restriction on the number of comments we can make. And we don't want a lot of empty field in the database. How do we solve this? Again, to achieve first normal form, we have to give each entry its own tuple. Can guess what its results look like? Yeah, it will be like this. In this table, represent each comment in its own row. If we think the number of the comment is important, we can add another attribute comment number to store this. Naturally, many of other columns have now repeated value, but we don't worry about this while we obviously this first normal form. We leave this for second normal form. Second normal form eliminate partial dependency. First, we have to check whether the relation is in first normal form. In this case, it is because it is outcome of our previous normalization step. Now that we are convinced that relation is in first normal form, we can begin to analyze candidate key and functional dependency. To make things easier, we remove some row to have more space. Examine the table for candidate key. We assert that prop number might be good one. A prop address is determined by it. Instead, inspection that does not depend on anything really, but it's defined the inspection in combination with the props number. Inspection time is defined by prop number, properties prop number, and inspection date, because we can assume that a property will not be inspected twice on the same day, so we don't make it a key. If there are several inspections a day, we should have to use the time apart a key that defines the inspection of property. Comment is inspection specific, and we have already observed that prop inspect that can unique define an inspection. So like the inspection time, comment is defined by prop number and prop address. The staff number who conducted the inspection also inspection specific. If we know which inspection we are talking about, we can also tell what staff number conducted it. If we remove the prop address from the table, all the other attributes are uniquely defined by the composite key of prop number and inspect date. This is our inspection tables. Putting prop number and address into a separate table gives us property table. The prop number in the inspection table can now serve as foreign key to the properties table. You can see the advantages is that the property address has no repeat anymore. This table is in second normal form. To achieve third normal form, we first have to check whether the table is in second normal form. The inspection table is the outcome of our investigation of second normal form, so we will know it is in second normal form. To bring a table into third normal form, all we have to do is check the transitional dependency and eliminate them if found. As you remember, transitional dependency are situations where an attribute is dependent on the primary key, but it does not really need the primary key to be unique defined. We can see the staff number depends on the primary key. If we know which inspection we mean, we can also tell the staff number who conducted the inspection, but the staff is redundant. We only need to know the staff number to be able to tell the staff name. So although the staff number and name are uniquely defined by the primary key, the staff name can be determined by the staff number alone. So we have a transitional dependency. So if you remove the staff name and put into a separate table, we have eliminated the transitional dependency. You can see there is a less redundancy. Only the staff number has duplicate value. This cannot be avoided if we want to preserve the link to the staff table, so that we can tell who conducted an inspection. The staff number serves as foreign key to the staff table, so that we can make the connection between inspection and staff name. Both tables are now in third normal form. We have established previously that they are second normal form, and now we have removed the transitional dependency by making a second table for staff. So we have a third normal form. When we look at repeating group with 1 and F, we have this example where multiple comments were allowed with each inspection. So we know from experiment that this table is in 1 and F. But is it in 2 and F? Pause the recording, think about the solution before you continue. As you become familiar with the rules and the fact that I always aim to remove redundancy, you will suffer from the repetition in the sum column. This table is normalized in our certification. But how do you check for 2 and F? Right. You have to analyze which attribute depends on which key. This is probably easy by now. You can tell which combination of key leads to, yes, you derive any other attribute without any doubt. The nasty surprise is the key that describe entities are almost all different. And there's a lot of combination. What kind of the table does this leave us with? The answer is on next slide, and it may not be anyone's test. You may not be happy with this result where we mean reduce redundancy. Now we have a lot of sum column in different, but you remember, in the initial model we don't mind additional column. It's duplicate value row that we don't like. Nonetheless, many participants will say I rather keep the original combined table from the last slide. This valid decision is called denormalization, and is often found in real application. As long as you understand the implication, having to take care of duplicate values and the quantity, you can denormalize. So the key is any column or set column that can be declared as a primary key instead of real or natural key. Another practical approach is to remove the composite foreign key. From the child registration and placing it as a key. In relation, there is an obvious unique ID field that can be used as the primary key. Staff ID, property number, order number, invoice number are example of ID field that are well suited as unique identifier. When we have such field, it is recommended that we use them as primary key because they have a real meaning. The PG coding for property number were here no doubt follow some Naming convention that actually tells the real estate people something. But there is no obvious ID field. Let's make one. Any decentralization database product has a tool called auto number or auto increment or similar. If you find a field as such a number, the DBMS will take care assign unique number to this field automatically. We don't have to do anything where you add a new tuple to a table. The key gets created by the DMS. A protection situation, people use this surrogate key extensively. So, as a summary, here are the most important points discussed in this model. You may not stop the recording, have to read through them. When you are ready, start the quiz about this model. So, as a tutorial, what do you have to do? Bring into first number, explain and apply. I divided the rating to become a meal rating and staff rating. Okay, so please answer this thing in Canvas discussion. This question is refer to the previous slide, previous lecture. Even though this question don't have any marks, but it relates with the test you guys will going for. I will put this thing inside our Canvas discussion. Thank you.